Hello, geometry, and welcome to video 1 for lesson 4 for covering proving and applying the ASA and AAS congruence criteria. This is going to be 2 more ways to prove triangles congruent to add with your side, 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 and your side angle side. Notice that today is more angle focused, right? 2 angles per congruence criteria. All right, so it says explore the angle side angle criterion, okay, congruence criterion. So it says, how many possible triangles can you determine when given 2 angles and the included side? So 2 angles and the included side. That's why the side is in between the 2 A's, right? So if we have in this picture here, right, we have a 25-degree angle that's not going to change and a 3-centimeter side AB. So angle B is the side that we're going to change, and we're going to see how many triangles are possible anytime we change angle B. So give me a second to get my Savas loaded up. All right, so let's take a look here. So notice it says, notice that once the 25-degree angle and the side length of 3 are set, there's exactly one way to complete the triangle with 68, 57, or 45-degree angle. So what we're going to do here is we're going to take a look here. So we're going to set angle B, all right, to the angle of our choice. So it says, what if angle B is 68 degrees? Well, let's swing this around, G, so that angle is 68. So notice that there is only one triangle here, right? Where these 2 sides intersect, that would complete the triangle. So there's one triangle. What if it's a 57-degree angle? Again, you notice still only one triangle, right? Not multiple triangles. But a 45-degree angle, still only one triangle, okay? So the idea behind this is that when you have a side, they call it AB, and then 2 angles, angle A and angle B, the angles on the sides of that side, right, so that the side is in between, there is going to be a unique triangle. Only one triangle that can be made. All triangles with the same 2 angles and included side will all be the same, will all be congruent, right? So that's the idea here. So the angle side angle congruence criterion says exactly that. It says that if 2 angles and the included side are congruent between 2 triangles, then the triangles are congruent. So over here, right, you have the A and the S, that's angle 1. You have the N and the T, that's angle 2. And then you have the included side, right, the side in between. Notice that we named that side with the 2 angles that are congruent, right? Angle M and angle N are the congruent angles to S and T, so it's MN and segment ST that are congruent, right? Good. So let's see if we can prove this using some transformations. And again, this is not always the most prettiest of slides, but I will do my best here. So it says, given that the 2 triangles have 2 angles congruent and the included sides congruent, prove that they're congruent. So, and name the angles with 3 letters. So LMN is angle M, right? RST is angle S, right? I will use 3 letters too, but you know, that's what it is. So first thing we're going to do is we're going to do a translation, right? It's always nice to line up one corner with another corner from the triangles. So first thing we're going to do here, we're going to translate. And we're going to translate triangle LMN so that we line up M with S, so that M maps onto S. And what this means is that S prime is going to equal M. So I'm going to slide this triangle this way. So now this is M prime. And all of this will stay the same. So this M to L will go down right around there. That'll be L prime. N will come right around here. That's N prime. And there we go. So that's the first translation. And again, M prime is still congruent to S. N prime is still congruent to T. And what is it? M prime, N prime, that side is still congruent to ST. Okay, number 2. Now we're going to rotate. We're going to rotate triangle L prime, M prime, N prime. And when we rotate it, we want n prime to map onto t, right? So what this means is that, what this means is that, oh, I said this one wrong. I'm sorry. I got to come back here for a second. My apologies. So this means that S is going to equal M prime. I think I said it, but I wrote it down wrong. I apologize, right? S and M prime. So now up here, right? So now T is going to equal N double prime. We're moving triangle element. So I'm going to rotate this guy up here. So this is still M double prime. Now N double prime is T. And L will come somewhere out here. I'm going to try to make it nice so it looks like out here. Perfect, right? And there's L double prime. Again, these two angles are still congruent. These two angles are still congruent. And now this side is congruent to itself. Yes, because they're touching. Okay. And now last but not least, number 3, we are going to reflect triangle L double prime, M double prime, N double prime over ST. Over ST. Now notice that they're touching on S and T, right? So that side is a part of both triangles. So now in this picture, right, notice that already established is that angle when we do the reflection, right? So now these triangles will line up, right? This will now be M triple prime, this will be N triple prime, and this will be L triple prime. And again, the angles are still congruent, the sides still congruent. So now notice that angle L triple prime, M triple prime, N triple prime is congruent to angle RST, and angle L triple prime, N triple prime, M triple prime is congruent to angle RTS, right? What this is saying is that because these angles are congruent, that must mean that L triple prime lines up with R, because look here, right? L triple prime is the first letter, R is the first letter. So L triple prime equals R, or R equals L triple prime. I should say so. R equals L triple prime. And what this means is we have all 3 letters of triangle LMN mapped to triangle RST. Okay? So we did find a composition of rigid motion. So a composition of rigid motions exists, which means that triangle LMN is congruent to triangle RST. Oh, I'm sorry, MLN. I'm sorry. You should use their lettering, right? Anytime you do a proof, you should use their lettering. Why would they go out? I don't know. So MLN, I'm just following this, is congruent to triangle SRT. And that proves, right? This proves the angle side angle congruence criterion. All right, so let's do one problem here, and then that'll be done with angle side angle. All right, so this question says a technician installs cables from a cell phone tower to the ground. To pass inspection, both cables must be the same length. Does this installation meet the cable length requirement? Explain. So the real question is, right, if I label this picture, call this A, B, C, and then call this D. The question is segment AB, this cable, congruent to segment CB, that cable? That's the question, right? Well, if we can prove these 2 triangles are congruent, then yes, the cables will be congruent. So let's take a look. Well, first of all, they give us these 2 angles are congruent, 52 and 52. So I know that angle ABD is congruent to angle CBD. That was given to us. It's on the picture. So there's one pair of congruent angles. Okay. Next, I know that this side BD is congruent to BD, right here. Because it is a part of the left triangle and the right triangle. It's congruent to itself. If I were to split the two triangles apart, that side BD would go with both triangles. So we call that the reflexive property. We have not gotten into that very much this year, but that is one of your properties of congruence and equality, the reflexive property, because it's a shared side. If we do more and more triangle congruent proofs, you'll see that often. Okay, so we have an angle pair, and we have a side pair. So now in order to use ASA, we would need these angles down here to be our second angle pair. Well, if this is a right angle, then this is going to be a right angle, and right angles are congruent. So we know that angle ADB is congruent to angle CDB. This right angle is given to us. We assume this is a straight line because it's the ground, and all right angles are congruent. And that's our second angle pair. We have angle, side, angle, congruence. So we do know that triangle ABD, the triangle on the left here, is congruent to triangle CBD, the triangle on the right there, and that is by angle, side, angle congruence. And because those two triangles are congruent, now all of its corresponding parts are congruent. If you look at the naming, AB is congruent to CB, and those are the two cables. This is by corresponding parts of congruent triangles are congruent, CP, CTC. And because those two segments are congruent, yes, this does meet the insulation requirement. So the requirement, require, what am I doing? G, you need a Q. They're close. So the requirement is met. Here we go. And that's a typical triangle congruence proof, where they're touching like that. All right, great. So that was the first video. You have another video coming up very shortly.